Evgeny Zobnitsev is my name, and I work at Factor Group, and I represent one of the representatives of the members of the program committee. So if you don't like this program, so you have any amendments or comments on it, so you're always welcome to listen to you and so to tell us what new things you want. And I'd like to come out with this tutorial, and I don't want to turn it into a presentation or a lecture. I want to really try just to talk about Netconf Young and so managing configuration and equipment. And if during my presentation or during the demonstration, a demo, you have any questions, so stop me, and because you cannot actually sit non-stop for an hour and a half and listen to me talk. It's boring, and I want. So since we have this very informal, nice audience, so we would like just to make it interactive. Also, Netconf Young doesn't have any future, etc. And so I'll come out with my own viewpoint on it, and I'll be happy with your comments, your doubts, and shared experience. Something that you have already tested and it didn't work out. So then I'll divide it into two parts. First I'll go over this slide deck to be on the same page, and then we'll discuss the same terminology, and then I'll talk about this topic that the tutorial is all about. And just I'll run over these protocols that are of interest, how to orchestrate and configure. And then I will give you a brief overview of Open Daylight. And then eventually these components will put together, and they will make it into something interactive tutorial. Interactive, just to do the demo, and so I gave it some thought. So we need several buttons to show how it works. Anyway, so if let me begin now. Why? So first I need to tell you why. So this network configuration management, why it's so important, and it's been around for many years in the network management, and why they still failed to address this issue, and why are we talking about network configuration management right now? Why? Because I think that the equipment of different network vendors. Naturally, vendors, so due to this competition and the different properties of their routers and their switches, etc., they have different functions, different networking functions that are used. And naturally, so it worked out that. So there was no standard. There hasn't been any standard how to write CLIs, and there is no such thing as and each vendor, they have their own proprietary CLIs. What is CLI? Raise your hands. Do you know what CLIs are? Oh, good. Many know. Good. And I'm trying to understand if I start just moving into the terminology, and so then interface of the command line of, so then you enter it, and then you configure your hardware. Then each of these things have proprietary APIs, programmable interfaces, APIs, and proprietary. So it's non-standard. It's impossible to get this model all this unfortunately ended with us having just to configure the network manually. So let me ask you, who configures manually the network equipment? Manually, right? And there's about 60–70%. Yes, raise their hands, and so that we can conclude that. So we have not addressed this issue. That's obvious now. I didn't hear that. Yeah. You see, when you do it manually, you have to use your brain as well. That's true. And so when we do this manual configuration, so we write the scripts, different languages, modern, not very modern, and so when we do our own automation of expect scripts, etc. Then the task is quite challenging, and because our scripts that we write to automate, they address one very important goal. It's impossible to make a certain abstract and lack of abstractions. And so to automate it for any vendor, because vendor changes his CLI, they change their APIs, and every time you have to rewrite your script. And then it brings about that as we do this screen scrapping, so we launch those scripts, and then we scrape them, and so we see what the hardware brings onto the equipment, and try to automate. So this interface was invented to operate, so it's interaction, not machine to machine, but man to machine. And everyone remember this good SNP protocol, SNP, and that allows us to work with the equipment. With the security is not the only issue there. I think that everyone who tried SNP to make any management system to work properly, and they would go to a website, download the proprietary MIP, upload into the system, then launch it, and then when the software updated, and then you missed it, and nothing works again. And so then with SNP, it's simple, but in spite of this fact, the problem has not solved these problems, and so we're all waiting for from vendors so good working telemetry collection. So we wait for them to deliver that, but not yet forthcoming. And so what we have right now, that the service life management, service life cycle management, when we do the service for our network, so want to have all the transactions simultaneously. We need to automate creating the service, changing the service, and want to automate it all, and so on, and removing the service automatically. And not only with the so when to configure this line, who wrote it, let's find and punish who did it. And so say, this is exactly so to make sure that it's automated and that all the lines are working in the equipment, so they would belong to a certain service. And when you remove the last service using this, using this function, so this line would be removed as well. So that's what we want, just to have this life cycle action. So that's our wannabe, but it's. Why it's bad? Because all the changes in the network, you have the network APIs of those elements, our script that is a certain controller. It acts as a controller, and so there is a representative model of our network. So the services, the composition of them, and each API point, the way it's described here, after any change of any operating system, and there's a change of elements, replacing them, changing of vendors. You change APIs everywhere, the whole stack. So I have just to write it all anew from scratch. That's why StatComs in the last 30 years of their, so they try just to approach this subject. And we have seen many systems. There's the orchestrators. That's a buzzword now. Provisioning of services. And so that the task has not been resolved, because when with the growth of functionality and other vendors appearing in the network, you have to write it all anew. So where we're heading and what we would like to see. So heading, and first, that the network configuration and the management system, orchestration, should be all model-driven. Model-driven, so we need to identify a certain model. So what do we mean by model? So it's structure of data. So the model can be just a set of data that you need to configure. And to configure, you don't need much data and automate it. You don't need too much data. You have a point of BGPIS, API address, interface on the router. That's all you need. Policy you need, right? What else? Then you can take it without policy. And if you remember the previous session, no need for a policy. And then this is also some data is required that you need, and that creates a new service for you. So knowing this data, this set of data, you can automatically do the mapping of one model of data to another model. You can generate the APIs. You can generate so all the way down to the network elements. And if in our spam, each of the elements of the system will provide information to another one, so there is I'm a new element of the system, right? So at the bottom, you can see network element, network element model. So the new element in the system appears, new configuration appears, a new vendor comes up, a new software comes up. And then it can explain to the controller in standard language that this is my data model, that my configuration, this is the configuration parameter, and it's located there or here. And this data model, if you have it, you know what you want to configure. So you can do a simple mapping can be generated. So you can map one data model onto another data model, and you can get this opportunity to manage configuration easier. But if you do it, so we can just support the life cycle, because once you updated the software, and so then you have this network elements, you generate an alert, you say that the data model got updated, software changed, so please so upload this and this. So how it's happening, and that's what we're going to talk about. This what are the protocols? What models look like, why it's so important, and what RFCs exist. And Ignas was saying, he was talking about IETF, that's in IETF. So we have special group, net mode group, that discusses new things and discusses the things that doesn't work properly. So this is a live system. The continuously changing system, and and if you are involved in it, if you are interested in this domain, you sign up for it. You come out with your proposals, changes, updates, so anyway, so always share something that you cannot resolve, cannot solve, and so because you need good engineers who would help you. How to do it, in our so then having this network element and having an API, so we can just always upload this system in the live connect, live into the controller. The controller, knowing the language, it's written in. so can compile it, and then changing this data structure, we can manage the configuration. And having this mapping between one vendor and another vendor, and now how to go from configure from the root where it is the JPIs, and the number is vendor 1, vendor 2, vendor 3, 4, and you can, knowing all that, how to configure, you can just do a simple mapping structure at the controller level, and have this multi-vendor management of your services and configurations. And this is quite straightforward, very promising. But at the same time, we can take a few virtual routers, and we'll talk later. We'll try to launch a couple of virtual routers and get an access to SSH and access and to manage them through Netconf protocol, and to get young models and try just to factor them in at the controller level. So that this is the whole. This is all about tutorials. So we have an automatic notification of our applications, and so that organize the services, and about that there are changes at the network level. Notifications about that. Now, so the first protocol from a number of protocols that allows us to manage and move towards our model-driven future. Our future. Don't know how to translate it into Russian. How to properly phrase it in a better way in Russian. This is this bright picture that I had drawn for you. The first protocol, RFC 6241. So this is our favorite Netconf. It's been around for a long period of time. And so there are new changes coming into it until now. And when I did this tutorial a year ago in St. Petersburg, we spoke about its functionality. Now I'll show you the difference between what we had before and have now. So additional functionality has been added to support a network configuration. But Netconf protocol originally was made to manage configuration of network elements. And in order to manage the configuration of network elements and do it reliably, for this you need so we need transactions, right? There we need a commit. We want to have these transactions, and everything that has to do with the theory, database theory. When every change should have a chance to go back and to make certain rollback, and every change should be separated, isolated, so that we could go back to it. And at the beginning of this, long way with the network equipment, so it was very difficult to do. So Cisco iOS is bad. It's not because they're bad, but because they have more experience with a certain operating system, and then the changes were applied at the time when they were keyed in. But if you don't do it right, then you lose your network. So you can certainly roll back just to get to the console level, or just or send an engineer to restore the system. And that is why. So that's and in the morning we spoke at length. Some of the compared operational team and development team co-sharing. So who has the wider knowledge and understanding, and so Cisco iOS-based systems, so they were right in doing it using Cisco, based on Cisco and iOS. But the protocol was developed specifically to have a chance to operate with config and have commit what you're used to, and so then modern equipment, Juniper, 6art, Nokia, etc. And practically all commit, rollback, etc. All came to the same functionality, the functions that we really need to have this functionality. So the functionality of the network elements, certainly we will network wide and have a chance that each of the elements of our service would support this transaction. Then we want this protocol to be vendor dependent. Vendor independent, because proprietor problem should be resolved. And so my MIP, this kind of MIP, and I have that kind of MIP. And so the MIP that conforms and operates equally well. So is an interface MIP, is a USNP, and so which you can easily question and get a predictable result. And this is very good. And this Netconf has certain Netconf sets up session. So it says the hello message, like an XML document, which is put over the SSH session. So I'll show you how it works once we do the demo. So I wanted to do it during the presentation, but I'm afraid it will freeze. So hello message, and we get back. So capabilities extension. They say who we are, what we can do, and what functions we support, and so what RPCs we have to run, and all about the box. And then we can do bat config operation and get this configuration. And then configure, then commit, all this on the wire at the level of the protocol of configuration. They implemented it with the help of Netconf. You have commit its RPC, a remote procedure call that's done on the box, and which commit does. And the most popular, most important commits we have right now implemented. Netconf has been implemented in 6022 RFC Netconf monitoring, which gives a chance to was a get schema, the automated manner, knowing what functions the hardware has. We can ask this hardware to give the young model of this hardware to us. So this is all software. No needs special knowledge. So we just will open up this console through Netconf of the hardware. So we just put a Netconf session RPC implementation. I will get the list of what the hardware supports, and we can get the model. Having gotten the model of data, so we already have a chance to do different things with it. So how the configuration of the device is configured. So then we have now two versions, is 1.0, 1.1, two versions of Netconf, and naturally, so then there are some extensions that allow from Netconf server to get from this Netconf server what functions it supports. So if we refer how it was done in St. Petersburg a year ago, and compare this to benchmark how Netconf server worked a year ago, and then hello messenger, all capabilities were there, all capabilities, all properties that they have in the box, they immediately were part of the hello message. Hello message declares what capability. Then the vendors are departing, are abandoning this approach. this kind of announcement of the box capabilities, and they migrate to the in-depth config monitoring, so we can question and can query, especially 1.1, so young library, which 7895 RFC that allows to sign up for changes, to changing libraries. So you can sign up for the box, for the functions that it supports. And so if Netconf, any questions or no questions? If not, just we'll go further. So let's go back to when we'll do the visualization, the demo, we can have questions. RESTCONF now. RESTCONF is the next protocol, and IETF and all of us were moving towards. We follow the internet development, and we can see that the majority of large operators, telco operators, they are closely connected with the soft skill content providers, and we can see that the majority of the operations, transactions that are done in such big systems, they use HTTP, web or PC technologies, web technologies to do it. So Netconf developed when Netconf was developed, so in the web XML. But the idea was that not to declare the only way to manage the hardware, but to give all possibilities that are closer or the closest to those who develop the code and use the RPC data. So then 8040 RESTCONF appeared as a result. And Netconf,
like or similar of using the REST protocol. The difference is important. So between this one and the ordinary REST full protocol is that what we use YUM to determine the configuration model. So used RESTCONF, you can ask the RESTCONF device. So what are the libraries that you have? Use the libraries, and you can get a list and models of data directly through, from the device. You don't need to ask admin to download it someplace. And instead of the relevant XPath.xml language for search and XML document, Netconf, you use urine encoded path expression. They are similar in general. So why I say REDCONF Live? Because if you look at the RESTCONF operation and HTTP header of RESTCONF, you see that there is mapping of one to another. So get operation is get config operation in Netconf. So if we send an inquiry, get an inquiry, so you get the same configuration. Post is edit config, and then create and replace, and so on. And so there is mapping between those RESTCONF, between the two. Now we are approaching, after considering transport protocols, we approach the protocol that I was asked to translate into Russian. And I don't know how to do it. There's understanding that IETF, it was called yet another next generation, some kind of acronym. A new next thingy that everyone will want. That's our everything, yeah. as they tell me from the front row. Well, there's RFC 6020. That's the language describing our data models and for configuration models. Unlike UML, who knows UML? Who used it? Well, we have some programmers. UML is about information model, so you can write everything, develop everything. But Young was made to describe configuration. It's an ideal match for Netconf. If we have transport operation in Netconf, that we may perform on the hardware, but Young describes what exactly is config, what data where should live, and checking the Young model, we shall remove at least some errors, syntaxes and other spelling. We shall know where the configuration lies of that, say, in the tree that we are searching. This is language to control keeping the configuration and describing network configurations. Looking at the Young model, you see many old things. If you ask Cisco, or if you used Cisco or Juniper, probably the same terms: interface, Ethernet, that were IP address, and there are many things, and because you do it several times a day. And Young model normally goes the same, follows the same logic, and you will see the root of the Young tree, and then live interfaces, or the list of interfaces, and then depending on the vendor, if is a good vendor or not exactly, not very. I'm just kidding. In some places, on the old boxes, there was no list. There were gigabit fast Ethernet, 10 gig interfaces, and you know those vendors if you use them, and 4 different lists, not one. So we had to write many workaround depending on the interface type. So I was trying to say a joke about the list. So again, Young tree, normally, if you see the CLI structure, it will look approximately the same. CLI, normally, at the moment, generated from the Young model. It's a consequence, not the source of the Young model. Roughly speaking, all your devices, if they are quite modern, have kind of a data model to configure line cards. You have those line cards, PU, factory, fabrics, and each of the elements can forward packages and process packages, make lines, maps, and rewrite. And it is all present some operations that have to do with configuration. So this is a data model that can be managed, controlled in the hardware. Is a Young model. So it usually is developed in Young. And your CLI, either HTTP or SMTP or RESTCONF, Netconf interfaces are all generated from this Young model. So initially, the hardware vendor presently, because there are many vendors, they're different, so you don't even, some don't model, but first they make a beta model and see the properties of their equipment. They write a Young model and then automatically generate all other boxes. That's why oftentimes we see that CLI goes like, as if you follow, as if you descend the tree of the Young model. It's important. Well, the last item is important because vendor must create and publish young models. Vendors must create and publish, and better to give away with the box through ETF Netconf monitoring or young library. Speaking about young 1.1 models straight from the hardware. For us to get what I described, what we want to get, and semi-automatic way to get the upgrade that something has changed. We need this feature. And if you have a vendor and he claims he's model-driven and he made his configuration from the model, but you don't have a programming way to get this model, or they tell you go to JEP Hub and get it, it's lying there. This, again, is one of the options, well, of the reasons to think and probably make the next RFP that the young model. So I should get those young models automatically from those devices. And presently, the new young version 1.1 was released, RFC 7950, and here I have put some key changes. I'm not going to list all of them. It's rather for you to kind of study separately. And the main thing that I noticed, when you go to the hardware and don't see nothing in the messages except mentioning NConf monitoring or young library, so the server supporting young 1.1 and Netconf 1.1 should remove advertisement from the message, hello message, so, and describe in a standard way in the library NFC that I said 7995 or EDF 6022. Again, so many numbers, they're all in the presentation, so we mean that both ways means automatic, getting the model automatically out of the box. So it's maintenance release that fixes the defects in the original spec. So you get a number of functions that the user, that are important for the user, and so I don't think that presently it is relevant for this audience. It is a text file, module example. That's what we say, model-driven. That's how the model looks approximately. This is a text file that describes all your data structure. So it's like config. It's a mix of config and config scheme. So you describe where in which place of your tree you expect the data to be. So in this case, we have NPLS module, and XSpace is important, as we often work with Netconf, and we announced that MSpace in order to work with the connected addresses and data. And then you see everything that you expect to see from any programming language. You can import, include, augment, refer to other data sets. So there is nothing big except, as I say, what we can describe it all. There is a standard language, and this language is a box. So getting this text file on the console, we can compile it and see how this data structure looks and so on, and change the data structure. If you make a DB at your controller, this DB, again, young defined, so the changes, and if you change your data structure, you, in most cases, you can automate the process of adding this data into your DB in order to keep the upgraded data. So you will not have to control it manually. It will be done in an interactive way by the controller. So it's like automation. You will forget about the way it works from the point of view of tracing the releases and just monitoring it in your control system. I actually stole this picture from a blog. I'm afraid to name incorrectly, Benoit. So I liked it. Benoit shares. So looking at what we have been discussing from the point of view of service registration domain, so young data model described at the young language, described in the young language, so the models can be sent through XML and JSON, depending of encoding, and through RESTCONF and Netconf protocols to the relevant application. Application will understand the structure of the data, automatically can perform code generation for the relevant programming languages that you use. So roughly speaking, most of the mapping and other things is meant as a protocol. From the tools point of view or utilities point of view that you use working with the young model, probably it's a young validator utility. It is also a code generator and many other things wrote by Martin. I couldn't actually spell the surname. It's on the slide. Sopian. If you wrote a model, how can you make sure that it's right? You take the text file, feed it to the command line. If Pyong doesn't tell you about an error, so you are successful. But usually it doesn't happen. Usually there's a number of messages, and Pyong can be used for including the libraries to check. It will do it. It will select and connect and whatever, switch on. And probably a popular capacity is use of formatting a presentation of young model as a tree. So the young tree allows you to determine the location of things. And the file that we saw in the text file, if you feed it to Pyong, you will see the name 3 VPN endpoints, and there's RT in endpoints without the reference to the P device or interface. This is a young model of a service 3 VPN in order to build a model of service configuration and check. Among utilities, you have Pyong to watch and validate and SymPy model, to get ETF from IETF drafts, and as young model is a text file, if you take any RFC that now refers to the new functionality, so this young model is there straight in the RFC. You can take it and copy-paste and feed to the validator. But in order not to do it manually and to have a chance to check in a cyclic manner, that's all. It's all SymP as a product of IETF hackathons during IDF to search for new ideas. So young tool list, that's a list for further reference. There is Open Daylight young tool. If you write something for the Open Daylight controller or ONAS, they have their own runtime and young tool libraries. and Young Explorer. Probably we have the picture here. It's a Flash-based browser-based, a utility that allows you to visualize if you don't like the command line. But I think we don't have such people in the audience, as we see that we all grew up from the command line and we shall keep enjoying it. And the Young Development Kit is an open source development of Cisco Ethernet, the generation code that is good to use if you have a Young model and you want to generate the necessary library and bindings and use your languages. SIMP. So all the tools are available at the youngcatalog.org. If you develop new models, if you decided to make a new Young model, please, I recommend to first go to youngcatalog.org. Probably it's there. And you don't have to invent a wheel, a bicycle. So all the relations between the Young model, I selected ETF IP, and all the connections to ETF dependencies describing the type of interface and all other configuration parts. We have them here, and what's the status? Blue is the accepted, the approved, green, red, and compilation files. When the draft, the Young model is there, but yet not through Pyong. And I guess if I go back to the previous slide, there is one more word about the Young catalog and database search. Last year, an important event took place. Models, OpenConfig, IETF, BBF, and the other standard bodies merged together. And you don't need to invent a bicycle or a wheel, even if you produce your own hardware and routers or your service. Just look, and there's Live3 APN, and there are many things made by the community, and that has become a standard. Not to waste too much time, I'll quickly speak about the open daylight, and then we shall make the session interactive. Question and comment about OpenConfig. It's not, it's not as bright as your picture. It's much more complex than you told. First thing, it's not criticize. What you are telling is a very good and necessary thing, but OpenConfig is a modeling paradigm. It's not a model of another organization. It's an approach. Probably I shall, stay here. It's an approach to modeling how information is presented, and nodes, elements, leaf, whatever. If we take routing, there are protocols, prefixes, and other parameters and interfaces. How IETF models? So the same Young is used. Young is a domain-specific language. If you are familiar with a database, it's its structure of database. IETF models and OpenConfig models are simply various schemes that carry similar but not the same information, and you shouldn't take IDF part of IETF models and just join them to other part of config models. These are different subdialects of the modeling methodologies, not the language, but the modeling methodologies. For instance, and the difference, the main difference, which is important, between OpenConfig and Young 1.1 is a presentation of operations data. That's the visual difference. For instance, you configure BGP route or whatever and make an equivalent. So what does it mean? It doesn't mean that you just enter the config into the platform, that BGP session has been established. Does it mean that BGP session tried but failed? Does it mean that there are some logical errors like wrong address family, wrong number of the autonomous system? And speaking about the practical configuration, at least there are three parts of information that describe configuration. It's what we want to config and what the platform accepted, and that's what the platform is using. Intended, applied, and drive configuration. If we config BGP session, it can turn out, technical term is a data store, sub-database. Our view, as far as I remember, Microsoft SQL uses the view terminology when you can take a chart and have different data. And once we configure the BGP session, it gets into the intended, but it doesn't mean it's active. Maybe the address is unavailable. When the session start, then it appears in the applied. And parameters, for instance, you config the whole time 270, and the other side 90 BGP negotiated to 90 sec. In your configuration, 270, but 90 at the protocol, and the configuration will show you the values used in real, used in fact. How does OpenConfig do it? Just making a copy of all these three, and one tree would be used for configuration, and another tree would be used for reflecting parameters. And IDF has a different approach to this, and not all leaves are duplicated. Some leaves have operational value, and for that, it's not the only reason why they are not compatible, but this is the main difference in the modeling approaches. Does it mean that IDF models are broken? No. Does it mean that OpenConfig doesn't know what they do? No. It's just different approaches. Thank you for the comment. Complementary information. Yes. I had the slide, but I cut it off. I put the, probably I shouldn't have skipped it because I caused the situation. OpenConfig is another view on how the configuration could look. OpenConfig probably has a dream that cannot come true. Let us all the trees. Let us have all the trees and all configuration look alike. I don't mind. That's a good goal. When I meant that OpenConfig, EBF, and other models were merged, I meant that having this conflict, looking at this conflict, they are under one governance and one search engine. At least they compete no more from the point of view of the technology. They are rather different views to the same DB. But OpenConfig will be open or won't be OpenConfig. It depends on the efforts of the operators community. If they can just pressurize vendors to make it, to make it good. Presently, all the vendors implemented OpenConfig. The only vendor who implemented more than OpenConfig was Cisco, but then we have native models, ITF models, OpenConfig models, and something else. So we are still yet to figure out how to interwork. So is it like, only one will remain alive? So everyone loses because OpenConfig does not work on the server. If you want to build this service model, EPN network device, you only have network device service models made in ITF. Presently, they are interoperable with OpenConfig. So there is still way to go, much work to do, but it's a promising opportunity of automation of everything that we clearly see. So I'll spend another 5 minutes to open daylight, and then we shall try to be more interactive and start discussing the future development. Open Daylight, I use this project in this presentation in order to, well, because it's written young, it uses through MD-SAL, model-driven service adaptation layer. So each service starts with developing a young model, then you generate the frame, and then the calling function, and Open Daylight is an open source controller that has been around for the last 5 years and rather probably well known in the professional circles. Some vendors use it, some not. There's lots of, criticizing because meritocracy and Open Daylight allow to deploy it every function in a special way, but it's not about Open Daylight, but about the project in existence and used in our demo.
In order to show how RESTCONF works, Netconf and Young, to show the properties, and so our controller device will include our virtual routers. External application will be using RESTCONF's API, and with the help of RESTCONF, we'll be adding or removing routers, and so we'll be able just to manage. So the whole idea behind it is like this. So what I want to show you, and that so having this controller, MD controller, what MD cell open divide, and so in the runtime. So we'll just launch this open divide. We'll tell so this fix this node, fix this node, and the entire tree, configuration tree that was configured within this node by Young, so it starts to look as the XML living tree in its holistic nature. So we have just one entry point, and so then you have actual derived configuration. That you will get it as a proxy queries from the boxes. This is not what's stored in the data store just given to you, but this is what currently that's what tells you what the router tells you. So having access to this kind of store, so you can write applications and manage with different communications that you have fixed and calibrated. So as protocols, we'll be using Netconf, RESTCONF up, and Netconf down, so then. But in Open Daylight doesn't have top or bottom, but it's just fixed calibrated resources and added to the tree. I will not talk about this. So lots of projects running, and so then Java application over Java network, then Apache Karaf, then so this feature A, feature D, then Apache Karaf. Now this will be, I will leave it for later. Yes. Now just we're coming to the description of the demo for the so Vernet VerNet Lab. This is for the demonstration purposes. It's a new project. Christian Larson from Deutsche Telekom. So it's an open source project that allows to look to send the images. So with virtual routers and like a Docker container. Docker container launches one process, Lidirt, and then Cisco, XRV, Juniper, JOS, Remix, Arista, etc. And so that it would be part of your CI network. So if you develop a service, you need to be able to check it. And thank Ignas to follow up on it and add it another configuration, because there is not one but three. And we need to check about this right configuration and whether the service has been restored, whether the session went up, and also whether the service is up and running. Very important. So using this project, so you can easily elevate, so bring them up, this virtual domains and the routers. So you simulate. So how you check the properties of your service. That's how Christine is used for the check of the young models of your services. So I'll show you as we do the demo. And so just ending this, I wanted to say this is a Meetup open source Linux Foundation, the Meetup platform. On Meetup platforms you can sign up. Soon we'll collect. We'll set up a new user group to explain the projects related to open source and networking, Moscow. If you're interested. Okay, shall we? Will you switch over to? Yeah, thank you. Now let's try to launch it. So we were talking about Netconf. Can you see it well? So this is the first line, SSH session, and the virtual corresponding to the virtual router. So you recognize this login, password, prompt. What I forgot. If you want to launch Netconf session to your SSH client, you need to add the query snetconf, the call, telling the remote server that you don't want the console, but Netconf session over. This is what you want to do, telling it to sort of over SSH. And so this is what we get back from the device. Name Cisco, XRV Cisco. This is the so-called hello. This is the hello. Now just going back.
Протокола, который поддерживается, и, соответственно, hello сообщение, в котором есть просто список capabilities. В capabilities в данном случае мы видим это Netconf Base 1.
Yeah, so this is supported 1.1 server, and as a server we have this virtual router as a server, acts as a server. So we support ETF Netconf monitoring, so all capabilities there, all. So then this device goes to the hello title, hello title. So if we talk moving into the future, then the next release releases. So Cisco will have to remove the capability from Hello. If you have an access to the latest versions, I think 6.0 something, 6.10 something XR, then you won't see so many. That's a long list of capability. You won't see them because 350 lines as Hello is in the way. It's too bulky. And so then the IETF Netconf monitoring, young library, RFC, has all these hellos. They all say that we need to remove them into a list of library. These all hello messages that you can sign up. That's it. If you would do the same with the Juniper, then
Juniper нам ответит более скромным списком, да, вот, в котором расскажет о том, что
and then it supports, unlike Cisco 1.0 Netconf, and it supports confirm, commit, validate. It supports that, right? If you see it well, I'm not sure. So let's identify that. Candidate, confirmed, commit, confirmed, commit. I read it here. Validate. That's what it supports. And then eventually that this vendor supports ADF net monitoring, as we can always query it further because we know what kind of functions it supports. So we know now if it supports commit or not. We know that as well, and we know that in electronic form. So whether there's no need just to open up the browser, so we'll just go to our vendor. From vendor, no need to go there and talk to then and so I can connect to the Juniper. Not to do copy and paste. So then open that com session. You say hello. If you answer to hello with your hello, so you can do RPC. Then RPC. Let me do it manually, so that I wouldn't think that I went to special delete. Okay, this is my. I don't remember by heart. So then I have this. So this crib has to help me with it. So this. That's very convenient, as you see. Paste. We do the paste, and like a good citizen. Sorry, just I'm speaking to the mic. So we answered hello and our message from our server with our message. We told them that we support a lot, and then we can continue now. Just this server, our server, and then we can go on. And then RPC, we can do it with the help of RPC. We can perform this one. Perform.
сделаю paste сюда соответствующий функции.
And so then please give me the list of your young modules. If the device tells us that it supports Netconf monitoring, then I answered hello, give me the list of all your young modules, and then the device answered, here you are, this is the list. So we have module ping, we have the 3 roads, and we have this and this, we have this trace route, word, safe, etc. So the device answered us, telling us what we have. And then the module in point is called configuration, because we're after this module. And all, and the Juniper, and the Juniper, so then vendors and configurations, the whole configuration tree is done as one RPC, as one young model configuration, as one tree. So you can imagine how difficult to parse this module, because it takes 9 megabytes and to get this module, and it's quite difficult. And I think that in the follow-up releases, Juniper will do like Cisco did and other vendors did. So they will, they will just break it down into functional blocks. So that currently we do in our terminal. And so we have this 1724 Junos that I've done them. The list of modules have generated. Now I've done paste into our session of configurations, and see all 9 megabytes worth of text as a young module available right from the box. What it gives us, that actually knowing Netconf, know standards, young, if you know it all, you have the entire gamut of the module configuration of Juniper, the way it looks with all the specifics. So in previous lives, someone tried to automate. Before that, we supported some interfaces for configuration. The remaining functions were not supported. And this one very important and very promising things to come related to this. And this Atom plugin, if they use Atom editor, it's a good plugin not to do it again. And it's not a Control-C, Control-V of different terminals, not to suffer with this and go through all these motions in the internet. If you want just to go around it, then there is a plugin. It's free plugin of the company. You can see on the screen. And so these examples and the scheme and all of the things that I listed is very convenient. You take them all, and you can. It's easy to Netconf session. You generated it, and then Netconf session is set up, and then you can send Netconf query and get the list of modules, like I was getting it from the console, and get the schema, that schema and running config, Netconf request. And then you get the relevant config from the relevant router in the structured scale. And that's moving further, so understanding how Netconf works and understanding that we have YAN, we can take it one step further. And further is to take, for example, I move over to the other terminal and to launch open the light as in the form of Karaf application. And then managing this device, this controller, once it's launched, is done with the help of any REST at anyone who can, any utility that can do REST, a standalone postman application. So it's very difficult just in this resolution to identify it. And so you can see I get request, get query to the server, and I would from this RESTCONF to get operational topology for Netconf. If the server is uploaded, if the server is loaded, then it sends a topology. Currently, it's open. The light is clean, just download it, and it's unpacked, but topology is there, and so the system answered. It means everything is okay. Then, in order to fix it, you don't have to configure anything because it's all in the form of dynamic requests. So then the mount Cisco operation is put RESTCONF config topology, not CO2, node CO2, open the light. I tell open the light. It's just a few parameters, how to name it. I tell the address where to take it from and in what port. So this password login, you don't have to remember. And then I tell them where to put all young modules that we have on the device. That's it. So after I have sent it for calibration, the same with Juniper, and we get eventually Juniper. I go too fast. So we need to do some troubleshooting. I got it. 10 minutes. 10 minutes for troubleshooting to prove that it could be operational. Yes, we need a witch doctor to make some incantations to make it go. Yeah, found it. I just closed it by mistake. So what we have, our topology. This is the our topology. After we ask open the light to add two more devices, IP address and the password. We didn't say anything to Cisco Juniper. That's it. Open the light generated Netconf sessions, two sessions, and it got all capabilities in the form of young files and put it in the cache directory. So then you can work with these devices, and so they're fully operational, and you can ask Juniper config to, and the mount point doesn't exist. Get operational. Disconnected. Juniper answered. It's still connecting, and it's why it doesn't show anything. It's not connected yet, but it's connecting. And what the main principle in runtime, we tell the application where the devices are. And so they generate a session. Netconf gets hello, and establishes this session, and then does one config. And then you can have 3 configurations and do whatever you want. You can just write your own applications, automate, express, whatever. So once you get them, you can play with them. So I suggest we finish at this. I will show you in 5 minutes that it will become operational. But while we're waiting for it to become operational, so I'm happy to answer your questions. So you can tell us that young has no future. Maxim Rayevsky, Veru. I'm sorry, I have to switch on Rayevsky. So, but I came for this presentation because I saw this word Netconf. Very interesting, very important subject, and I really want just to learn more about that. So that's I'm from the 2 worlds. So I'm in the current life. I work with the network in my company in the last, and in the previous life I was involved in software. And so there's two heads. So this story was for whom? I'm not just probably target audience. And as the first question, there will be more questions. So this story, the story was kind of aimed at between the first and the second, right? Your previous life and your present life, because we have an understanding that to operate networks, impossible to be CLI. A person who learns technology and continues to work with hardware and knows the protocols, and to be a software guy who is involved in APIs, deals with APIs, models, etc. So you cannot do both. And so then it's passwords, the words. So we're talking that we need eventually to kind of. So to become something in the middle. So we need to be both. Yes, we need to be this is quadrant. So the knowledge of protocols is not needed. No, I never said that there is no need for the knowledge of protocols. But you remind me of such guys. So the Netconf, it's a step back, right? And so this automation. So I will have this very simple task. I will have to remove Cisco and add Juniper. I will have just to transfer config. Netconf can help me with that or not? No, it won't. And why do we need this abstraction that you've been talking for an hour and a half about? So this I started with some controversial arguments. It's a picture of the world. So then everything will be up and running and it will be all automated. It's a beautiful picture. And Netconf Young could help you if your services in the network work modeled, all of them. So if your network and all the models. So no, I have simple tasks, not services. So I have a bodyguard and I need to migrate him. So we're not talking about services. This is later. So the mapping of the services, so the function that everyone likes. So let's throw out Juniper and put in Cisco. Let's remove Cisco and put in Juniper. It works only if you map. If you map as a programming engineer, so one model on top of the other. So you can change the mapping, but knowing the structure of the data. Only then it's possible. So I can do it, but I have to do it manually, right? To develop, I need to do this mapping by hand, manually. Yes, if you're a good citizen currently, right now, if you want just a new service to configure in the network, not to open the console, to go to the console and do it manually, but to check and to fix the module service and then augment it and put it on the new one. Okay. Are there any more questions to keep Maxim happy, or just he will just eat all the time? Roman Timofeyev, Mega Group. So the question has to do everywhere. You have XML slides, but Gisona answers you. The vendors agreed in what kind of language, the Gisona or XML, and how, what kind of language they're using Have they agreed on that and how it can be intermapped? Yeah, so yes, both. Yes, you can do. I showed you this slide, this Benoit slide, and this is when we were talking with the controller with the help of RESTCONF interface. And since I am old and bold, I use Netconf. I tell the controller, and the controller speaks to me back in JSON. So this is both work. They are all operational. Both are operational. The second question. You talk about young model development in the command line, and so if I want to form from the code, what is it that we have? If I want just to take it from the code and develop, and so what kind of instruments? Can Young help you? Can help me? Yes, the Kit, Cisco, Bindingen, Go Python, C++, C. So there are, if it's Java, and then if it's your world, so then you're welcome, and you can. This is doable as well. And so it either. Okay, one last question. No more time. No more time, unfortunately.
So Google promised to open source. They support 7 or 8 languages for plan generation, so it's just about to happen. If you have BGP without, and you need XR, then Young model will work for you if you just retrieve configuration. Cisco and put Juniper and configure to the state, and well, it should work. I believe we should wrap up here if there are no more questions.